Alright, so we're going to take a look at logarithmic differentiation. We've actually done this a little bit previously, but I'm going to make it official. So you're going to do 2 lines, make a tab for it. So just a few things to remember from our preparation for calculus. Log of a plus log of b is equal to log of a times b. Log of a minus log of b is equal to log a divided by b. Log of a raised to the b power is equal to b times log of a. So this is just for preparation of calculus. So we're going to use that to do this example. Alright, so step 1, take the natural log of both sides. So let's go ahead and do that. So we're going to get log of y equals log of this entire other side. Then step 2 would be use the log rules, the natural log rules, to separate into pieces that are easier to basically differentiate. Alright, so let's separate. So we've got log y, and then what does that say? That's divided. So when you're dividing, you can subtract by taking log of each thing using subtraction. So log of the top minus log of the bottom. Alright, number 3, then take the derivative of both sides. So the derivative of natural log from our previous one is 1 over y, dy dx, because we're differentiating y, equals 1 over that thing, times the derivative of the inside, which is 1, minus 1 over the whole thing, times the derivative of the inside, which is 2. Alright, so number 4 would be simplify and solve for dy dx. Alright, so simplifying this, what can we do? Alright, so we can multiply everything by y, multiply everything on the right hand side by y, leaving just dy dx equals y times this other side, and then we just got the numerator 1 times 1 is 1, and negative 1 times 2 is negative 2. Number 5, step 5 would be to substitute y. Now I'm going to put this in parentheses. We don't normally substitute y unless it needs to be defined only as x. So again, we don't normally substitute y unless it needs to be defined only in terms of x, if the question tells you that. This is a listening check. Color in the number 5. Color in the number 5. So what was y equal to? From the very first line, y is x plus 3 over 2x minus 5 times whatever we already had. We can simplify this a little bit more, but we're just not going to waste some more time of it. Now this seems a little hectic. It's easier just to take the quotient rule, and I agree with you. However, there's some examples where using this method actually helps and it's quicker. For example, let's take a look at those kind of things. So let's say we had this. Trying to do the quotient rule, the product rule, and the chain rule, man, this is too much for all that. So in cases like this, the logarithmic differentiation is easier. So take log of both sides, so log of this whole thing. And I'm going to write this in exponent form so that I can be ready. So to the 1/2 is that one, and this one is to the 1/3. Alright, so then use the log rules to separate this. So what log rules can I basically use? So I can do each individual log because I know when I multiply, it's like you're adding individual logs. So we can do that there. So we can say log y is equal to log of this first thing plus log of this second thing. Alright, now what can I do? Now I can just bring the power down. So I would say log y equals 1/2 log of this thing plus 1/3 log of this whole thing. Now what else can I do? Well, now I have the quotient rule within that, so now I can do subtraction, right? So I can say log of the top minus log of the bottom. So I would have log of y is equal to 1/2, and I'm going to put this in parentheses just so I don't get confused, because the 1/2 is times everything inside that parentheses. So log of x plus 3 minus x minus 5, just breaking it down. Okay, that's the first little piece right there. Plus 1/3, and then open a parenthesis so that you don't get it confused. And then we're going to have log of 2x plus 7 minus log of 5x minus 1. So now we've broken everything completely down. Well, it makes it very, very simple to take derivatives of this. So take derivative of both sides and use an implicit differentiation. So what are you going to get? You're going to get 1 over y dy dx, because it's a y, equals, now the constant is just going to stay the constant, 1 over that minus, or times the derivative of the inside, minus 1 over that times the derivative of the inside, plus 1/3 1 over that times the derivative of the inside, which is 3, minus 1 over that times the derivative of the inside, which is 5. Alright, now we need to kind of simplify this a little bit. So we can multiply everything by y, so we're going to get dy dx, and we're going to get y over 2 in this first little piece. And then inside we can combine the numerators, so 1 over x plus 3 minus 1 over x minus 5, and then same thing here, y times 1/3, and then combine the numerators as well. This is a listening check. Color in y over 3, and once again that's it, unless the question specifically tells you that they don't want y's in the answer. Alright, let's take a look at one more. So let's say this is what we had. So again, it's like the quotient, chain, and product rule. So take logs of both sides individually. Use a log rule to separate them. So log of y equals, then we can do, the top is multiplication, so it's been adding individual logs. And then the bottom is division, so it's going to be subtracting the bottom. Okay. Now what can we do? Okay, we do the power rules on both cosine squared and that last function, last piece of the function. So we're going to get 2, because that's cosine squared, so bring the 2 down, so it's going to be 2 log cosine minus 5 log x3 plus 1. Now take the derivatives. 1 over y dy dx equals 1 over that times the derivative of the inside, which is 2x, plus 2 over cosine x times the derivative of the inside. What's the derivative of cosine? Negative sine x, minus 5 over x cubed plus 1 times the derivative of the inside, which is 3x. Alright, now simplify it and solve for dy dx. So we're going to multiply everything by y, so it's going to be y times everything on the right, so 2x minus 5 over x squared minus 5x, minus 2 sine x over cosine x, minus 15x over x cubed plus 1. Alright, what can we do? Okay, well, we know sine x over cosine x is tan x, so we can simplify that a little bit more. It's a listening check. Color in dy dx. And I'm not going to go any further into making this more complicated, so this is actually enough. That's fine. And that's pretty much it. So that's logarithmic differentiation. Sometimes it's easier to